So let us now move on to the next question. Next question is again from vector calculus, and it says that if the function f of xyz is given to be x cube plus y cube plus z cube minus 3xyz, then a point at which the gradient of the function f is equal to 0 is which among these four? So we are to tell what is the correct option here. So let's see for the solution part. Now, first of all, let us calculate the gradient of the function f. The function f of xyz, that is given to be x cube plus y cube plus z cube minus 3xyz. So the gradient of this function f would be calculating del by del x I cap plus del by del y j cap plus del by del z k cap of the function f. F is x cube plus y cube plus z cube minus 3xyz. So that means we will calculate the partial derivative with respect to x of this function, and then it would be I cap, then the partial derivative with respect to y of the same function into j cap, and then we'll have write partial derivative with respect to z of the function with respect to multiplied by k cap. So let us calculate the partial derivatives here. So partial derivative with respect to x would be 3x square minus 3yz, right? This is I cap, and then with respect to y it would be 3y square minus 3xz, this would be j cap, and then for third term it would be 3z square minus 3xy, this would be k cap, right? So this is the gradient of the function f. But in the question, if you look at the question carefully, they are asking the a point at which the gradient of function is equal to 0. So let us equate this gradient as equal to 0. So if you equate this gradient as equal to 0, that means 0 means we are having the vector, this is vector 0, because on the left hand side there is also vector quantity. So that means it would be 0 I cap plus 0 j cap plus 0 k cap. And now in case of vectors, two vectors, they are equal whenever the components of I they are equal, the components of j are equal, and the components for k they are also equal. So let us do that. So we have 3x square minus 3yz is equal to 0. This is one equation. Another equation is 3y square minus 3xz is equal to 0. And the last equation is 3z square minus 3xy is equal to 0. So you can cancel out 3. So this would be x square minus yz is equal to 0. This would be y square minus xz is equal to 0. And this would be z square minus xy is equal to 0. So from here you obtain x square is equal to yz. From here you obtain y square is equal to xz. And from here you obtain z square is equal to xy. Right? Now you have two options from here. So you have method number 1. So in method 1, what you can do, you could check all the options here and see which option satisfy all these three equations simultaneously. Right? So let me do that for you. So the first point here for the first option is given to be minus 1, 1 and minus 1. So let me substitute it here. So we have minus 1, 1 and minus 1. This point. So when you substitute this point here, so here you can clearly observe that the quantity x square is not equal to yz, because minus 1 square is not equal to 1 into minus 1, right? Obviously. So this option is incorrect. Now you can go for option B. Option B says you check for this point minus 1, minus 1, minus 1. So it will satisfy all the three equations. Because here in this case minus 1 square is equal to, for the first equation, minus 1 into minus 1. For the second equation, minus 1 square is equal to minus 1 minus 1. For the third equation, minus 1 square is equal to minus 1 minus 1. So these three equations, they are correct here. For the third option, we have the point minus 1, 1 and 1. So here, if you look at your equation, your y square would not be equal to xz, because y square would be 1 square and x is minus 1 and z is 1. So this option here is not correct. So this point is not a valid point because here the gradient is not equal to 0. And for the last point, we have 1 minus 1, 1. So accordingly, here the condition z square is not equal to xy. Why? Because z is 1 square and your x is 1, y is minus 1. So here obviously 1 is not equal to minus 1. So this is also incorrect. So here we obtain option B. This is according to method 1. Moreover, if you think about this more logically, so this will take you to method 2 and this would be less time consuming. So if you apply the analytical side logic here, you have these three equations. So now if you look at this more clearly, this x square being a square of some quantity is always positive, this y square is always positive, and z square is always positive. So that means for x square to be positive, the right hand side should also be positive. So this should also be positive and this should also be positive, right? Now this to be positive, that means the sign of y either you have negative negative or you have positive positive. In this case also either you have negative negative or you have positive positive. And for the third case also you have either negative negative or positive positive. So here, from here you can see that in all the conditions, so because you want the same signs of x, y, z, so that means simultaneously, so we can conclude in the second method that the signs of firstly, we have written down this to be yz. The signs of y and z in equation x square is equal to yz, and the signs of x and z in equation y square is equal to xz, and the signs of x and y in the equation z square is equal to xy, they should be same. If the signs should be same, that means the signs of x and y and z should be same. Overall, should be same. From here, if you look at your options, so according to your options here, the same signs are only obtained in the option number B. So here, from here we conclude that our option B is the correct option. So I hope you understood this concept, right? This question, this was very simple question. Well, that is it for today.